The last topic in this section is difference quotient of a function. So it says the difference quotient of a function f at x is given by f of x plus h minus f of x all over h. And h cannot equal 0. All right, so what this is, okay, no matter what function you are given in the world, its difference quotient is defined this way. It is f of x plus h minus f of x all over h, okay? What this is something that is important in a calculus class, okay? As far as algebra is concerned, we are going to learn how to form difference quotients, okay? We're not going to talk about what they mean, okay? That is going to be saved for a calculus class. So like if you went on to 1325 or you go on to 2413, you will use this a lot, okay, and learn what it actually means. So again, don't worry about what exactly this is used for. All you need to be able to do for the purposes of this class is put one of these guys together, okay? And specifically, we're only going to learn it for a couple of different types of functions. For right now, you need to be able to find the difference quotient of a line. Okay, so your function will look like f of x equals mx plus b. Okay, remember that's y equals mx plus b. We haven't talked about lines yet in this class. That's coming. But anytime you see anything in this format, y equals mx plus b or f of x equals mx plus b, that is a line. Okay, the other type of function you're going to need to be able to find a difference quotient for is for a parabola, for a quadratic equation. And so that has the format f of x is equal to ax squared plus bx plus c, okay, or y equals ax squared plus bx plus c, okay. There's tons of types of functions, okay, but you only need to be able to find the difference quotient for a line and for a parabola for this class, okay? All right, so let's talk a little bit about what you see in the box, and then we'll start on example 7a, okay? So you're going to be given a function, okay? Like in example 7a, you'll be given f of x is equal to negative 4x plus 3, and for that function, you have to find its difference quotient. X and h are variables, okay? So the way I like people to think about the difference quotient, think of it as a recipe, okay? You're going to follow the recipe to put this thing together, okay? Break it down into parts, okay? If you look at this difference quotient, there are 3 different parts. You see f of x plus h, and then you see the minus f of x, and then lastly, you're dividing by h, okay? So that's what we're going to do. Okay, when you are asked to find the difference quotient, the first thing you're going to do is find f of x plus h. Okay, that is something we learned how to do in example 4. If you flip back in your notes, remember what that means. This means to go to your function. Everywhere you see x, you're going to replace it with x plus h. Okay, so you're going to replace x with x plus h. Okay, and remember you got to put parentheses around it. It's a package deal. Okay, so replace x with x plus h and simplify. Okay, that is the first step. You must simplify before moving on. Okay, and then the next thing you're going to do, you're going to take that result, okay, the result of f of x plus h, and you're going to subtract f of x. Okay, f of x is the original function. Okay, so in the second step, you're going to take f of x plus h and subtract the original function. And once again, you need to simplify before moving on. Okay, and then after all of that, that's going to give you the numerator, okay, and then you need to divide by h. Okay, so we're going to divide by h, okay, and then you'll be done. Okay, now just a word of warning, The more complicated your function is, the more complicated your answer for the difference quotient is going to be. Okay, so don't be alarmed if you get something kind of scary looking. Don't be alarmed if it has an H in it. Okay, that's fine. Okay, your answer may look kind of strange. Okay, all right, so let's go ahead and try this on example 7a. Again, it is nothing more than a recipe. We just need to follow the steps in the recipe. Okay, so here we go. By the way, you do not have to memorize this formula. It will be given to you. Okay, all right, so the directions say find the difference quotient of each function. Be sure to simplify your answer. Okay, so we're going to start off with a pretty simple function here. In part A, we've got f of x is equal to negative 4 times x plus 3. Okay, this is a line. Okay, f of x is the same thing as y, so this is y equals m times x plus b. Okay, so again, we'll concentrate more on lines in an upcoming section. Okay, all right, let's find the difference quotient. All right, break it down in pieces. If you try to do this whole thing at once, I guarantee you will end up making a mistake somewhere. Okay, break it down into steps. Okay, so step 1, we are going to find f of x plus h. Okay, that's this top part of the recipe. Okay, so this means go to the function. The original function is f of x equals negative 4x plus 3. Everywhere you see an x, you're going to replace it with x plus h. Okay, if you need to write this out to the side to do that, then do it. Okay, take the original function. Everywhere you see an x, you're going to replace it with x plus h. So you're going to end up with, let's see here, f of x plus h is going to be negative 4. Instead of multiplying negative 4 by x, you're going to multiply it by the package deal x plus h. Okay, that 4 is going to have to get distributed through. Okay, and then after that, you need to tack on the plus 3. Okay, you have set up f of x plus h. Okay, went to the original function. Everywhere you see an x, we put x plus h. Okay, we need to simplify before moving on. Okay, if you look at your directions, okay, make sure you simplify before moving on. That's very, very important. Okay, so what we can do here is we can distribute this negative 4 because we're adding inside the parentheses. Okay, so this is going to give us negative 4x minus 4h plus 3. Okay, that's it. That's as far as we can take f of x plus h. Okay, all right. So then in step 2, okay, what does that say to do? In step 2, we're going to take f of x plus h and subtract the original function. So we're forming the numerator. Okay, so we are finding f of x plus h minus f of x. All right, let's do it. Okay, so you need to write down f of x plus h. Okay, we just found it. Okay, so let me write this down. F of x plus h minus f of x. Okay, that's going to equal f of x plus h. That's negative 4x minus 4h plus 3. Okay, and then if you look at the recipe, look in the formula here, you need to subtract f of x. F of x is the original function. Okay, f of x is negative 4x plus 3. Okay, so we're going to subtract the original function. But be careful. The original function has more than one term. It's got negative 4x and it's got positive 3. You've got to make sure that subtraction sign gets distributed correctly to all the parts. So you need to put the original function in parentheses so that you distribute the negative correctly. So we're subtracting the original function. The original function is negative 4x plus 3, and I've encased those terms in parentheses. Okay, so you can clearly see the f of x plus h in yellow, okay, and then minus f of x in blue. Okay, we need to simplify. If you read the little instructions here in part 2, we need to simplify before going forward. Okay, so I'm going to write down negative 4x minus 4h plus 3. I can distribute this negative sign here and here. Okay, so that's going to give me negative times negative is going to be positive 4x, and then negative times positive is going to give me negative 3. Okay, and then combine like terms. Okay, At this point, no matter what function you're dealing with, okay, you can kind of gauge whether you're doing this correctly, okay? At this point, if you're on the right track, lots of stuff should cancel, okay? If you don't get a lot of things to cancel, you did something wrong, okay? And what I mean by cancel, you've got to have a term, you've got to have its positive version and its negative one. If you have two positives, they don't cancel. If you have two negatives, they don't cancel. You need to have a positive and a negative. So I see a negative 4x, and that's going to cancel with a positive 4x. And then I see a positive 3, that will cancel with a negative 3. And all that is left is negative 4h, okay? That is the numerator. This is f of x plus h minus f of x, okay? So now we can go on to step 3, okay? We've taken care of the numerator. So now, according to the recipe, we need to divide by h, okay? So in step 3, okay, we need to write down what we were left with in step 2, the numerator here, okay? And we need to divide by h. Okay, so then what's going to happen? You have an h in the top and an h in the bottom. H divided by h, those will cancel, and it's going to leave you with 4. Okay, and this is the answer to f of x plus h minus f of x all over h. Okay, this is the difference quotient. Okay, this is the answer. It's negative 4. Okay, this is a pretty simple answer. Okay, like I said, the more complicated your function is, the more complicated the answer will be. Okay, I will give you a little hint here. Like I said, when I first showed you this original function, this is a line. Okay, so this is y equals mx plus b. Okay, if you notice, we got negative 4 is the difference quotient, and you can see that negative 4 is part of the line here. Okay, it's the number in front of x. And if you remember, that's the m value here. M is slope. Okay, so here's a little hint. Anytime you are finding the difference quotient for a line, the answer will always be the slope of the line. Okay, always. That doesn't mean that you can't show me the work. Okay, so if I give you a line, a linear function, and I ask you to form the difference quotient, you still need to show me all the work, but you can check yourself. Your answer had better come out to be the slope of that particular line. Okay, so that's a neat little fact. Okay, so we're going to move on to example 7b now, and we're going to get a quadratic function. Okay, so that's definitely going to be more complicated, and we're going to find its difference quotient.